So hello, very good evening, good morning to all. Right. So yeah. So basically, what we are doing, क्या कर रहे थे हम लोग? तो हम लोग states of matter, that is the gas is a state. So ये कुछ question solve कर रहे थे, right? So in Saturday class also we solved a lot of questions related to the gas is a state and combining questions like from the JE as well as the NEET questions, right? In today class also we are going to solve some questions, right? So very good morning, JNV Bhavnagar and JNV राजकोट ठीक है गुड मॉर्निंग सो आज भी हम कुछ क्वेश्चंस करने वाले हैं रिलेटेड टू गैसियस स्टेट एज वेल ठीक है और आज कुछ अलग टाइप की क्वेश्चन सॉल्व करेंगे सो दैट आवर पूरा का पूरा हम लोगों का अच्छे से क्वेश्चंस कवर हो जाएंगे क्लियर है सो if you have any problem related to the audio or screen visibility you can just text me right so that इसमें कोई प्रॉब्लम ना चलो तो शुरू करते हैं क्लास आज का So the question is, ये क्वेश्चन मैंने तुम लोगों को होमवर्क दिया था दिस क्वेश्चन या दिस क्वेश्चन आई एम प्रोवाइड यू एज द होमवर्क क्वेश्चन सो आई होप सबने ही ट्राई किया होगा सबने ही सॉल्व किया है राइट किसी ने ट्राई किया था क्या because I'm going to discuss the solution of this question as well right चलो तो एक बार डिस्कस कर लेते हैं फटाफट so basically the question is for the real gas as 25 degrees Celsius temperature and the high pressure 99 bar the value of the compressibility factor is 2 the value of Z is given so the value of the interval constant B should be so you have to calculate the value of the interval constant B right so let's see how will you calculate this for the real gas. So one important note here, this is for the real gas, not for the ideal gas. So you cannot use the equation PV is equal to nRT here. You have to use the real gas equation. ठीक है? तो चलो. So we all know that जब हम gaseous state का derivation part करते हैं, so we know that for one mole, right? For one mole. तो मैं 1 मोल के लिए लेके चल रहा हूँ फॉर 1 मोल दैट इज n इज इक्वल टू 1 E that is V minus B is equal to RT. So this is the real gas equation when you take the number of mole for the 1 mole, right? So this is the real gas equation for the 1 mole that is PV minus B is equal to RT. Now just multiply this. So this will become PV minus PB is equal to RT. ठीक है? Now, just divide whole term by RT. So फटाफट डिवाइड कर दो यहाँ भी RT से डिवाइड किया यहाँ भी RT से डिवाइड किया और यहाँ भी RT से डिवाइड किया एक रिड्यूस फॉर्मूला बताने वाला हूँ लोगों को ठीक है सो ये क्या हो गया अब जल्दी से बताओ मेरे को दिस इज PV अपॉन RT राइट दिस इज PV अपॉन RT and this is RT upon RT or we say 1 और ये हो गया that is PV upon RT. So this is what we have. We all know that ना बेटा PV upon RT is what? PV upon nRT. याद आ रहा है किसी को? What is PV upon nRT? PV upon nRT is nothing but the compressibility factor that is Z. So this is Z. So Z is equal to 1 plus PV divided by RT. ठीक है? So Z is equal to 1 plus PV divided by RT. When we apply this equation for 1 mole and at high pressure, always remember this, at high pressure. So at high pressure, volume is negligible. So we just neglect the volume term from the real gas equation. So we get the formula like this, right? PV minus B is equal to RT. So where we have Z is equal to 1 plus PV RT. So this equation we need to derive, right? Z is equal to 1 plus PV RT. Now in this question, the value of Z is given, I guess, right? So the compressibility factor is 2. So just write 2, right? And this is minus 1. And this is equal to PV upon RT. What is the pressure? 99. P you have to calculate. What is R beta? R is given that is 0.083. And what is T? So T is also given, I guess, 25 degrees Celsius. Or we say 298 Kelvin. Okay? 298 Kelvin. So this is how we actually calculate this. See, कितना आ गया जल्दी से बता दो एक बार फटाफट. So 2 minus 1 comes out to be 1. So we can say that 99B is equal to 0.083 into 298. Or we say B comes out to be this upon 19. But simple. So this is how we calculate the value of B. So the answer comes out to be कितना आएगा? तो अगर आप इसको solve करते हो तो ये आंसर आएगा 0.249. ठीक है, but in this question they're asking in the power 10 raised to the power minus 2. So we can write as 10 raised to the power minus 2 like 24.9, or we say 25. So this comes out to be 25 into 10 की power minus 2. So the correct answer is 25. समझ आया क्या सबको? So this is very important question, right? This question, yes, JEE in 2022 में आया भी है ये. So this is going to be a very important and very good concept type of question. I hope this is clear to everyone. Anyone having any kind of doubt in this question, you can just raise your hand or just ask. Anyone? Or got it? Clear है तो भी confirm कर दो एक बार फटाफट. Clear, sir? Good. Chalo. Now move to the next question. That is a 10-gram mixture of hydrogen. A 10-gram mixture of hydrogen and helium is contained in a vessel of capacity 0.0125 meter cube at 6 bar and 27 degrees Celsius. The mass of helium in the mixture is in gram. So you have to calculate the mass of helium in gram mixture. So 10 gram of mixture of hydrogen and helium you have, and containing in a vessel of a capacity is this. So volume is given. So this is the volume, temperature is given, and this is the mixture, right? Mixture of what? That is hydrogen and helium. So we know the atomic masses of hydrogen and helium as well. And 10-gram mixture of this. We have to calculate the mass of helium. So this question is again from the, very simple question. And we can solve this question very easily, right? So what formula we are going to use basically? So basically in this we have mixture of hydrogen and helium we have, right? So we can say that the number of mole of mixture of H2 and helium. कितने होंगे number of moles of H2 and helium is? So we can say that PV is equal to nRT. We all know this. PV is equal to nRT, right? We know this. PV is equal to nRT. So you have to calculate the number of moles. What is the number of mole? That is PV upon RT. PV upon RT. So what is the pressure here? So pressure is 6 bar. What is the volume? So 6 bar we have now. So 6 into 10 is to the power 5, because we have to calculate this in gram, है ना? Newton per meter square. So bar में given है. So always whenever pressure is given in bar, you have to convert in Newton per meter. So for conversion into Newton per meter, you have to multiply by 6 into 10 raised to the power 5. 10 raised to the 5, you have to be multiplying with bar. ठीक है? So this is 6 into 10 raised to the power 5. And what is the volume given, beta? That is 0.0 0.0125, right? And what is R? So R we have like 8.3, and T we have 300 Kelvin. So from this you calculate very easily number of moles, right? This will cancel out each other, right? This is 2 raised to the power, this will cancel out 10 raised to the power 3, and 3 to the 6. So you can easily solve this, right? So on solving, you'll get the number of mole comes out to be 3. So let the number of mole of the mixture is comes out to be 3. Now, we know that number of mole 3 means what? Because in this we have a mixture of hydrogen, right? That is the number of mole of hydrogen plus number of mole of helium, and total comes out to be 3. This is what we get. Number of mole of hydrogen plus number of mole of helium. The total value comes out to be 3. Now, how will you calculate the number of mole? We know that mass upon molecular mass. So mass of hydrogen, that is the mass of hydrogen. We need to calculate mass of helium in this question. No? So mass of hydrogen divided by the molecular mass. So let the mass of helium in 10 gram mixture be x gram. So मान के चल देते हैं कि जो 10 ग्राम का मिक्सचर है, we have a 10 gram of hydrogen and helium mixture ना. So let us assume mass of helium is x gram. ठीक है, आउट ऑफ 10 ग्राम x ग्राम मान के चलते हैं मास हीलियम का है. सो ऑब्वियसली x ग्राम इसका है, टोटल 10 है, तो कितना हुआ हाइड्रोजन का मास? जल्दी बताओ. दैट इज 10 माइनस x ही तो हुआ. so that is mass, that is 10 minus x ग्राम अपॉन मॉलिक्यूलर मास, that is 2. हाइड्रोजन कितना हो गया? 2 प्लस x अपॉन मॉलिक्यूलर मास ऑफ हीलियम, that is 4. and this is equal to 3. सब इसको तो solve कर लोगे. So on solving, what you will get? ठीक है, इसको solve करो. So 2 4s are 8, 4 10s are 40 minus 4x plus 2x is equal to 3. So 40 minus 4x plus 2x. तो ये आगे हम लोग को solve करने पे 40 40 minus 2 comes out to be 40 minus 24. 40 minus 24 means what, beta? 40 minus 24, right? So this comes out to be 16. So x comes out to be 16 upon 2, that is 8. So कितना आ गया? 8 gram. So the mass of the hydrogen, mass of the helium in the mixture is 8 gram. कितना आंसर आया? 8 gram. समझ आया क्या सबको? जल्दी से एक बार बता दो. देखो क्या पूछा था, अ 10 ग्राम मिक्सचर ऑफ हाइड्रोजन एंड हीलियम, यानी एक मिक्सचर है जिसमें 10 ग्राम हाइड्रोजन है एंड हीलियम है, is contained in the vessel of the capacity this. So volume is given and pressure is given and temperature is also given. You have to calculate the mass of helium in the mixture. So first of all, what we calculate, that is the number of mole. How? That is PV is equal to nRT. So we can calculate the number of mole of the mixture, total number of mole of this mixture. Now जैसे हम लोग को टोटल नंबर ऑफ मोल ऑफ द मिक्सचर मिला, वी नो दैट टोटल नंबर ऑफ मोल है किसके, दैट इज नंबर ऑफ मोल ऑफ हाइड्रोजन प्लस नंबर ऑफ मोल ऑफ हीलियम. सो वी जस्ट ऐड नंबर ऑफ मोल ऑफ हाइड्रोजन एंड नंबर ऑफ मोल ऑफ हीलियम. सो वी equate with 3 because total number of mole is 3. We calculated already, right? Now total mass of the mixture is 10 gram. So let us assume the mass of the helium is x gram. Then what is the mass of hydrogen? Because total is 10 gram. So if one is x gram, then another is 10 minus x gram, right? And their molecular mass, atomic mass is already given of hydrogen and helium 1 and 4 U respectively. So we can just put the value and calculate the value, right? This is what we have. So this is also very very simple question. समझ आ गया सबको? एक बार बता दो. Got it? Eight gram. ठीक है, चलो. Now the next question is a mixture of hydrogen and oxygen. A mixture of hydrogen and oxygen contain 40% hydrogen by mass when the pressure is 2.2 bar. The partial pressure of hydrogen is in bar. So you have to calculate the partial pressure of hydrogen in bar as well. ठीक है, चलो तो देखते हैं फटाफट. Mixture of hydrogen and oxygen. So we have a mixture of two things, that is a hydrogen and oxygen. So we have to calculate the partial pressure of hydrogen. तो सबसे पहले जिसको निकालना होता है, always write the formula for those compounds. So we have to calculate the partial pressure of hydrogen only, na? So partial pressure of hydrogen is nothing but is equal to mole fraction of hydrogen multiply by total pressure. ठीक है, यही तो है फॉर्मूला. पार्शियल प्रेशर ऑफ हाइड्रोजन इज नथिंग बट मोल फ्रैक्शन ऑफ हाइड्रोजन इनटू टोटल प्रेशर. And a mixture of hydrogen and oxygen 40% hydrogen mass when the pressure is 2.2 bar. So total pressure is already given, that is the pressure 2.2 bar, right? So we need to calculate just the mole fraction. If you calculate the mole fraction of hydrogen, then we easily calculate the partial pressure of hydrogen as well. So how will you calculate the mole fraction of hydrogen? So the mole fraction of hydrogen is nothing but the number of mole of hydrogen divided by the number of mole of hydrogen plus number of mole of oxygen. This is what we have. Now let's calculate the number of mole of hydrogen first. So hydrogen, number of mole is mass upon molecular mass. So clearly in this question it is given that hydrogen and oxygen contain 40% by hydrogen. So 40% hydrogen है भाई. So 40% hydrogen का मतलब क्या है? That is mass is 40 gram, right? And molecular mass of hydrogen is nothing but 2. So we have 2. That is 40 upon 2. Similarly, we have 40 upon 2 comes out to be 20. Similarly, we have N of O2, that is oxygen, right? So for dioxygen, what we need to calculate? We need to calculate the values like, if in percentage, 40% hydrogen means what? 60% must be oxygen. हाँ, तो अगर कोई परसेंटेज में दे रखा है, if someone says कि 40% यहाँ पे हाइड्रोजन है, इसका मतलब 60% ऑक्सीजन है, बिकॉज मिक्सचर तो दोनों का है ना. So it means this is a 60%. So this is 60 upon molecular mass of O2, 32. So this also comes out to be 60 upon 32, which comes out to be 1.875. So you calculated 20 upon 1.87. Just put this value in this equation. So mole fraction of hydrogen comes out to be 20 divided by 20 plus 1.875. ठीक है? So on solving, what you'll get? You'll get around 0.914. So this comes out to be, that is 0.914. Just solve. This is a very simple thing. Now put this value in this equation. That is 0.914 into total pressure is 2.2 bar. So its value comes out to be 2.01, or approximately we can say that 2 bar. So the pressure comes out to be, partial pressure is 2 bar. Right. So the correct answer is 2. जल्दी बताओ, समझ आया सबको? कैसे किया? So every in any question, some basic terms are always required from your side, right? If you know this thing, that is a mixture of 40%, 60%, these all things we already studied this thing in the first chapter, that is the mole concept, when we're discussing about the molarity, mass percentage, mass by volume percentage, and all these things. So we know how to represent the concentration terms, right? So this thing we already know. Okay? Clear? Chalo. So this is what we have, that is a 2 bar, and 2.01 is equal to 2 bar. So this is what we need to calculate. Okay? So I hope सबको समझ आ गया होगा. चलो, move to the next question. A sealed flask with the capacity of 2 decimeter cube, right, contain 11 gram of propane gas. The flask is so weak that it will burst if the pressure become 2 megapascal. The minimum temperature at which the flask will burn is, बोल रहा है, a sealed flask है जिसकी capacity है 2 decimeter cube and contain 11 gram of propane gas. They contain 11 gram of propane gas. The amount of propane gas is given. The flask is so weak that it will burst if the pressure become 2 megapascal. So if the pressure become 2 megapascal, then this flask will burst. खत्म हो जाएगा, फट जाएगा. What is the minimum temperature at which the flask will burst? So you have to calculate the minimum temperature for the flask to be burst. ठीक है? चलो भाई देख लेते हैं फटाफट क्या है क्या नहीं है. So we know that you have to calculate the temperature, and volume and pressure is already given. Okay? So we know from the ideal gas equation. Okay? We know from the ideal gas equation what we know. That is, because we assume that because in this question it is already given that assume that propane behave as an ideal gas. So this is already mentioned. Okay? If propane behave as an ideal gas. Let's see. So we know that PV is equal to nRT. This PV is equal to nR and T. Right? This PV is equal to nR and T. Now, we know this PV is equal to nRT. What do you mean? P is given how much? That is 2 into 10 की power 6. Right? 2 megapascal. Pressure is given. 2 mega. Mega मतलब 10 की power 6. ठीक है? Volume is also given. That is 2 decimeter cube. Yani 10 raised to the power minus 3 meter cube. So this is the volume we have. R already we have like 8.3. And what about the number of mole? So number of mole is mass upon molecular mass. So mass is given, that is 11 gram. And what is the molecular mass of propane beta? Can anyone calculate molecular mass of propane? Propane means CH3, CH2 and CH3. So this is the formula of propane. So we have a 3 carbon, 1, 2 and 3. So 3 carbon means 12 into 3 plus 3, 3, 6 to 8 plus 1 into 8 hydrogen. So this comes out to be 36 plus 8. That is 44. So 44 is the number of mole. So this is 11 divided by 44. That is 1 by 4. Okay? Now, put all this value in equation 1. So we know P is equal to 2 into 10 की power 6. V is equal to 2 into 10 की power minus 3. N is equal to 1 by 4. R is equal to 8.314. ठीक है? And this is nothing but temperature T. ये क्या है आपका temperature? So this is what we have. That is the temperature T. ठीक है? Chalo, so we just need to calculate this t. It is 2 into 2, 4. 10 raised to the power, this become 3. This approximately 4 to the 8. So this comes out to be 2 into t. So t comes out to be 4 divided by 2 into 10 to the power 3. Or we say on because I took this value as approximately value, right? 8.314. So solving, you will get the value like 1927.7 Kelvin. ठीक है, एग्जैक्टली सॉल्व करोगे बिकॉज मैंने ये 4 टू द 2 पॉइंट समथिंग आएगा ना, 2.123 ऐसे कुछ आएगा. ठीक है. So on solving, you'll get the values like this. In degree Celsius, they are asking. They are asking in the degree Celsius. So for the degree Celsius, you just subtract value. So क्या करोगे? That is 19 to 7.7 minus 273 minus 273. So values comes out to be 1655 degrees Celsius. ठीक है, 1655 डिग्री सेल्सियस. सो ये हो गया 1655 डिग्री सेल्सियस. आई होप दिस इज क्लियर टू यू. क्लियर है ये क्वेश्चन? जल्दी फटाफट जल्दी से बताओ एक बार. एवरीवन. So this is what we need to actually calculate for such question, because in this question they're asked to ask us to calculate the value of this. So we can calculate the value like this only. ठीक है, चलो. Next question. The pressure of the moist gas. ठीक है, the pressure of the moist gas at 27 degrees Celsius is 4 atm. ठीक है. So the pressure of the moist gas at 27 degrees Celsius is 4 atm. The volume of the container is double at the same temperature. The new pressure of the moist gas. So in this question, try to find out which law is applicable basically. So this follow the Boyle's law, I guess. कैसे Boyle's law? Because the temperature remains constant, right? Whenever the temperature remains constant, they always follow Boyle's law. Always remember this thing. They always follow Boyle's law. So we know for the Boyle's law, what we know? That is PV is equal to nRT. This is the ideal gas equation. If T is also constant, because N and R is already constant, so if the T is also constant, then this whole term become constant. So this whole terms become constant. Then this PV comes out to be constant. So how will you write this? We write this P1 V1 is equal to P2 V2. So we can write like P1 V1 is equal to P2 V2. Okay? So we can write like this. P1 V1 is equal to P2 V2. Now, in this question, they're asking the pressure of the moist gas is 27 degrees Celsius is 4 atm. So pressure is given. The volume of the container is double at the same temperature. The volume container क्या हो गया? Double हो गया. The new pressure of the moist gas is. So you have to calculate the new pressure. So let me solve this question. Because you already know the value. Like which value do you know? Because you already know this thing, pressure of the gas, right? So the pressure of the gas at 27 degrees Celsius is 4 atm. The new pressure of the moist gas you need to calculate, right? So we have P1. So P1 is already given, that is 4 atm. Okay? So this is already given 4 atm. Now what about V1? So the pressure of the moist gas at 27 degrees 4 atm. The volume of the container is double at the same temperature. So double हो गया. यानी पहले अगर मैं इसको V मानता हूँ, let us assume this is V, and this is equal to P2. You need to calculate, and V2 is double. That is 2V, right? That is 2V. Good. Now you need to calculate this P2. So this P2 value comes out to be 4 into V upon 2V. V get cancelled. This will be comes out to be 2. So P2 comes out to be 2. ठीक है. P2 कितना आ गया भाई? 4 atm से 2 atm पे हो गया. So this value comes out to be 2 atm, right? Hence you have to calculate the new pressure of the moist gas, right? New pressure of the moist gas in 10 raised to the power 1 atm. So the new pressure, how will you calculate the new pressure? So the new pressure of the moist gas is nothing but this is equal to Q. Okay, so this is how we actually used to calculate this value. समझ आया? The vapor pressure of water at 27 degrees Celsius is already given, that is 0.4 atm. Okay, so इस point को भी नहीं छोड़ना है. So the new pressure of moist gas is, that is 2 plus 0.4, that is 2.4 atm. 2.4 atm, but then they are asking in the terms of 10 raised to minus 2, so we can write as 24, right? So this value comes out to be around 24. So that is 24 into 10 raised to power minus 1 atm. So this is the correct answer for this question. Okay. Now move to the next question. सभी लोग इसको एक बार सॉल्व करने का कोशिश करो. That is the 100 gram of an ideal gas is kept in the cylinder of 416 liter volume at 27 degrees Celsius under a 1.5 bar pressure. The molar mass of the gas is. So you need to calculate the molar mass of the gas. Fatafat, everyone, at least try to solve this question. Very simple formula in this they are using. Let me चलो ये भी बताया तो थोड़ा सा hint दे देता हूँ. PV is equal to nRT they are using. By using this formula, please, I'll give you 1 minute for this question till I take some water. So अभी 1 मिनट के अंदर आप सभी लोग क्या करो, मोलर मास ऑफ दिस गैस निकाल के बताओ चैट बॉक्स में फटाफट. Within 1 minute, you all need to calculate the molar mass and यही फॉर्मूला यूज होगा, that is PV is equal to nRT. जल्दी से फटाफट. All need to calculate this value. Yes, I hope everyone calculate the value. Anyone? जल्दी बताओ भाई फटाफट, किसने वैल्यूज निकाला, किसने नहीं निकाला अभी तक. No one. चलो, लेट मी डिस्कस दिस थिंग. जिसने भी निकाला हो उसको मैच कर लेना, ठीक है फटाफट. So in this question they are asking molar mass of the gas. So we know that this N is calculated like PV upon RT. Now this N is what? Mass divided by molecular mass. ठीक है, mass of solute divided by the molecular mass, and this is equal to PV upon RT we have. ठीक है. Now we have all the values, right? Like mass, that is 100 gram of an ideal gas. Molar mass we need to calculate. Pressure we have like 1.5 bar pressure. Volume we have like 416 liter. R we have like a 0.083, and the temperature we have like a 300 degree. ठीक है. Now you can easily calculate this value. कितना simple था, कुछ करना ही नहीं था. You can calculate the value of M like 100 into 0.083 into 300 divided by 1.5 into 416. So this is how you actually calculate the molar mass. So in solving, you'll get molar mass comes out to be 4. ठीक है? So this is a very simple question. ठीक है? बहुत ज़्यादा simple question था. You just need to calculate the molar mass by using a simple formula of PV is equal to nRT, because already in the question is mentioned that the question is from the ideal gas. So whenever the ideal gas question is there, so you need to calculate the molecular mass on, right? So the molecular mass of the gas comes out to be 4. किसी का आया था क्या 4 ग्राम? Any one of you? जिसने भी ट्राई किया हो सॉल्व करने का, किसी का भी आया हो 4 ग्राम? चलो, move to the next question. That is, the 2 gram of hydrogen gas is absorbed on 2.5 gram platinum powder at 300 Kelvin and 1 bar pressure. The volume of the gas absorbed per gram of the absorbent is dash ml. So 2 gram of hydrogen gas is absorbed on 2.5 gram of platinum powder at 300 Kelvin and 1 bar pressure. You need to calculate the volume of the gas absorbed per gram of the absorbent. ठीक है? So this is also a simple question. You just need to calculate the volume again. So again, use the same formula. So these questions are very easy, beta. Just you need to use the correct formula. We know again PV is equal to nRT. PV is equal to nRT. So how will you calculate volume? Volume is nothing but nRT divided by this P. So we can calculate volume by using the formula nRT upon P. Okay? Now what is N here? That is number of moles. So how will you calculate the number of moles? That is mass upon molar mass. So mass is 2. Molar mass is also 2. And what is R? What is T? So R we have 0.083. 0.083. And what is the temperature? And temperature is given 300 Kelvin. Pressure is already given. That is 1 bar. So just calculate this 2 to get cancelled. So just multiply 3 into 0.8321. So we can easily calculate this value. So when you multiply this thing, that is a 0.083 with this, then you can actually calculate the value. So we know the value of 2, we know the value of, right, 2 to get cancelled. So this comes out to be around 24.9 liter. Okay. So this comes out to be 24.9 liter. Now in this question they're asking the volume of the gas adsorbed per gram of the adsorbent. So what is the volume of the gas adsorbed per gram of the adsorbent? So for calculating volume of the gas, volume of the gas adsorbed per gram of adsorbent. ठीक है? So volume of the gas adsorbed per gram of adsorbent is nothing but 24.9 divided by 2.5. Right? Because the 2 gram of hydrogen gas is absorbed on the 2.5 gram of platinum powder. So the volume of the gas adsorbed per gram of the adsorbent, that is the platinum, that is 2.5, comes out to be 9.96 liter. Or we say it comes out to be 9996 milliliter. Because in this question they're asking in the milliliter. So we can write as 9960. So the correct value is 9960 milliliter. ठीक है? So I hope this is clear to you. सबको clear हो गया? चलो. Move to the next question. That is, at 300 Kelvin, a sample of 3 gram of gas A occupies the same volume as 0.2 gram of hydrogen at 200 Kelvin at the same pressure. The molar mass of gas A is 10 gram. So you have to calculate the molar of the mass of the gas, and it is also assumed that the behavior of the gas is ideal. So this is an ideal gas equation, so we can use the formula of ideal gas. Right? Now, temperature is given. Okay, pressure is given. So we just need to use the formula like PV is equal to nRT. Right? So if you use the formula like PV is equal to nRT, तो एक ही फॉर्मूले पे कितनी बार वर्क करता है? Like PV is equal to nRT. PV is equal to nRT. You need to calculate the molar mass. So again the same thing. P we know pressure is given, that is at 300 Kelvin, 300 gram gas occupy the same volume as 0.2 gram of hydrogen at the same pressure. Okay. So some conditions were given. That is, let us assume for gas A. ठीक है, यहाँ पे मैं डेटा लिख रहा हूँ फॉर गैस ए। तो गैस ए के लिए क्या कहानी है? गैस ए के लिए कहानी है कि मान लो इसका प्रेशर पी है। अगर गैस ए का प्रेशर कितना है? पी। ठीक है। टेम्परेचर कितना दे रखा है बेटा? टेम्परेचर दे रखा है 300 केल्विन। वॉल्यूम कितना है? तो वॉल्यूम मान के चलते हैं बी। तो प्रेशर पी हो गया, वॉल्यूम बी हो गया, टेम्परेचर 300 केल्विन हो गया। मास इज ऑल्सो गिवन। सो मास इज ऑल्सो गिवन। मास कितना है? 3 ग्राम। मास इज ऑल्सो गिवन। नाउ मोलर मास इज व्हाट? अगेन वी नो दिस। So from this equation, we can write the formula for this. That is P into V is equal to nRT. So N we write as 3 upon molar mass into R into T we have, that is 300, and put this equation as 1. Similar for the second, that is for a hydrogen. For hydrogen. For hydrogen, what we have? So for hydrogen, we have a pressure like P. Pressure we have like P. Okay. Now temperature is given, that is 200 Kelvin. Volume is V. Volume is V. And the mass is also given, that is 0.2 grams. Again use this formula. So this PV is equal to 0.2 divided by 2. Right. Molecular mass of hydrogen is we know na, that is 2. Into R into 200. So from these two equations, if you divide these two equations, you get the value of M very easily. Right. So from 1 and 2. So from 1 and 2, that is equation 1 and 2, we get the value like PV get cancelled out. So 3 by M into R into 300 is equal to 0.2 upon 2 into R into 200. This R get cancelled and we get the value of M like 45. So what is the value of M? Comes out to be 45. So the molar mass of gas A is 45 gram per mole. Okay. So this is what we need to calculate actually in this question, and we also calculate with that. That is the molar mass of the compound is 45 gram per. So I hope no problem in this question. सबको clear हो गया होगा? Anyone having any kind of doubt in this question, you can ask. No doubt, सबको clear है? ठीक है, चल. Move to the next question. That is an empty LPG cylinder. ठीक है. So let's see. That is an empty LPG cylinder weight of 14.8 kg. Right. When full, it weight 29 kg and show a pressure of 3.47 atm. In course of use at ambient temperature, the mass of cylinder is reduced to 23 gram. ठीक है. तो 29 से इसके मास को reduce कहाँ कर दिया? 23 gram. The final pressure inside the cylinder is. So you need to calculate the final pressure. Whether there is a change in pressure also when you decrease the weight from 29 gram to 23 gram, right? So you have to calculate the final pressure inside of the cylinder. ठीक है. Assume LPG of भी है ना ideal gas. So assume करना है कि LPG cylinder है वो ideal gas की तरह behave कर रहा है. ठीक है. चलो. So in this question, it is already given very interesting data like weight of empty, that is weight of empty. Weight of empty LPG cylinder. ठीक है. So weight of empty LPG cylinder is nothing but it is given, that is 14.8 kilogram. कितना है? 14.8 kilogram. Now weight of full LPG cylinder. So weight of full LPG cylinder is nothing but 29 kilogram. 29 kilogram. So weight of gas. Weight of gas. So what is the weight of gas बेटा? भाई फुल करने पे 29 किलो का हो गया और एम्प्टी सिलेंडर का वेट 14.8 है, तो गैस का वेट कितना हो गया होगा? ऑब्वियसली 29 minus 14.8, so it comes out to be 23 kg. So 23 kg उसके अंदर गैस भरा हुआ है. Then the weight of gas used, ठीक है, because they are saying that is in course of use at ambient temperature, the mass of the cylinder is reduced to 23. So mass reduced हो गया 23. The weight of gas used. Weight of gas used, that is 29 minus 23. ठीक है, 29 तो फुल था, उसमें से गैस कितना था? 23. तो 29 minus 23, that is equal to 6 kg at ambient temperature. Ambient, ठीक है, at ambient temperature. Now, for the ideal gas equation, we know PV is equal to nRT. Just you need to calculate the value. So, what you need to calculate here, beta? Pressure. So, you need to calculate the pressure on. Okay? So, let me discuss this thing. Look. Okay? So, 6 kg of ambient temperature weight of gas used we have. Now, for the ideal gas equation, we can say that PV is equal to nRT, and we can write as mass of the solute upon molecular mass into RT. So applying the ideal gas to the LPG cylinder when the gas is full. तो जब गैस फुल है तो वहां पे टेम्परेचर कितना है भाई? जल्दी बोलो, प्रेशर कितना है? 3.47 atm. तो ये केस 1 है. केस 1 कौन है? केस 1 जब सिलेंडर फुल है. जब सिलेंडर क्या है? फुल है. तो प्रेशर इज 2.7, वॉल्यूम इज V, and this mass is given, that is 14.2. This is the molar mass M, and this is RT we have. So this is equation number 1. Now अब लिखा case 2 when they reduce to 23 gram at ambient temperature. So again the P into V is equal to N, we say 8.2 upon M into RT. ठीक है. Now just divide this two equation. Again दोनों equation को divide करो. We have equation 2. So from 1 and 2. From 1 and 2. क्या क्या cancel होगा? RT get cancel. And this V get cancelled, so we get to know the value of P. So P values comes out to be 3.47 into 41 divided by 70. Okay, into 41 divided by 70. So this is how we do calculate. The value comes out to be 2.0038, or we say in approx we can say that 2. Okay, we can say that the value comes out to be 2. So I hope this is also clear. This in this question they're asking an MPG cylinder. This का weight 14.8 kg था. When full, its weight is 29 kg, and so a pressure of 3.47 atm. In the course of the use of ambient temperature, the mass of the cylinder is reduced to 23 gram. The final pressure inside the cylinder is, you need to calculate the final pressure inside the cylinder is, which is equal to. Okay. So this is very much similar question like this. So ये तुम सभी लोग इसको try करना एक बार. ठीक है. Try to solve this question. That is an LPG cylinder contains gas at the pressure of 300 kilopascal at 27 degrees Celsius. The cylinder can withstand the pressure of 1.2 into 10 to the power 6 pascal. The room in which the cylinder is kept catches fire. So you have to calculate the minimum temperature at which the bursting of cylinder will take place. So you need to calculate the minimum temperature at which the bursting of the cylinder will take place. ठीक है. So this is all about the LPG cylinder. So I hope this is a very much simple question like this only. So you all need to calculate. If you face any problem in this question, then I am going to explain this question, right? Because in this question, a very simple thing we are going to use. LPG cylinder contain a gas cylinder can withstand the pressure of these. The room unit of the cylinder can catch fire. The minimum temperature at which the bursting cylinder will take place. So in this, the relationship between the pressure and the temperature we have. So we know the relationship like P1, T1 is equal to P2 and T2. So just use this formula. So on using this formula, you can actually calculate the value of T2. तो इस तरीके से आप किसको निकाल लोगे T2 की वैल्यू को फाइंड आउट करें ठीक है so if you know the P1 P2 T1 T2 then T1 then you can easily calculate the value of T2 ठीक है so this is what you need to calculate from this question now move to the next question that is the pressure exerted by a non-reactive gases a mixture of 6.4 gram 4 gram of methane and 8.8 gram of carbon dioxide in 10-liter vessel at 27 degrees Celsius. So this question is from again that is the Dalton's law of partial pressure. So you need to calculate the pressure exerted by the non-reactive gases. Okay. So we know that PT is equal to what? PT is equal to NT into RT upon V. This is what we have now. This is RT upon V. So PT is equal to N into RT upon V. Now, what is the total pressure in this case? So we know that the total pressure in this case is P into V, right? So we can also write as this is the total pressure PT into V is equal to NT into RT. Both are same. Okay. Now PT we have no do not have a total pressure. Volume we have 10. So that is the 10 liter. So this 10 here and for the liter we have right. So carbon dioxide at liter. So this is 10. Now number of mole we have 6.4 divided by the molecular mass. 8.8 divided by the molecular mass into 8.314 multiply by 300. Multiply by 300. So this is what we have. So on solving, you can actually calculate this value of pressure. So on solving, you get the value of P around 150 kilopascal. Okay, 150 kilopascal. So this is the pressure exerted by the non-reacting acid mixture of 6.4 gram and 8.8 gram of carbon dioxide in 10 liter vessel at 27 degrees Celsius. Okay. So we already solved many questions related to this chapter. So this is all for today class. We already discussed many questions related to street matter like JEE and NEET question as well. Right. So just revise the whole concept. एक बार और पढ़ो, एक दो बार और पढ़ो इसको, एक दो बार और करो इसको. Then try to solve more questions. ठीक है. So we cover almost 2 to 3 years of last 2 to 3 years all questions in JEE mains as well as in the NEET questions. So just revise the whole chapter. Try to memorize the formula. Try to learn the formula. If you learn the formula now, then you can easily solve the question. Okay. So try to learn this all formula. Try to memorize this. Then you are able to form very well in this chapter. So from the next class, that is from the next Saturday, Sunday, we are going to solve the question related to the thermodynamics. So this is your work to just revise the concept of thermodynamics because thermodynamics is a very vast chapter. So we need to remember lots of formula. If you know the formula, then you can easily apply and the solution is very easy, not big deal. Right. So in the next weekend classes, we are going to see some thermodynamic question as well. ठीक है? Anyone having any kind of doubt, you can ask बेटा. किसी को कोई भी doubt हो अभी आज की क्लास में कुछ भी हो कुछ भी पूछना हो you can ask me. बराबर. No. सब कुछ क्लियर है? No doubt. ठीक है तो चलो एंड करते हैं मीटिंग को अगर किसी को कोई डाउट नहीं है तो ठीक है टेक केयर ऑल